acquired by IBM, and has been like a very famous analytical service of IBM recently. So this Norman Nye, who was founder of SPSS, has told that R is the most powerful and flexible statistical programming language in the whole world. So even who's actually he is a competitor, but he himself has acknowledged, saying that R is the powerful statistical tool. And a lot of other people has told that R is a true data language, and people has been telling that R is a language that has statistics and data built into its DNA. Okay, so when you see other languages, you see it's been used for multiple purposes. Okay, so but R is the one of the oldest language which is kind of built to only for statistical purpose. Okay, so this is not only used in the area of statistical computation, it's also used in the area of data analytics and visualization. Okay, so here they will be like working on the data, and we will be like applying algorithms on the data through R. Okay, so so in this tool that people are trying to not only solve the data problem, they're trying to understand the business. With the help of this tool, people are able to like understand the data and take insights out of it, and then so that they can help the business people to take decisions. So this is actually a data decision making assistance tool. Okay, so how this R came into being. Okay, so this R was like kind of developed in 1976. Okay, so long ago this platform was developed, and this is actually a modern implementation of S. There was a language called S. Okay, and then from S plus was evolved, and from S plus R is kind of evolved. Okay, it's one of a very oldest language, and actually this S was initiated in 1976 in Bell Labs. Okay, it's actually an American laboratory, which is like kind of founded by Nokia. I think everybody knows about Nokia, right? That's a company is founded Bell Labs in US. Okay, so this S was initiated in 1976 in that particular lab. Okay, so in 1992 R was initiated. So after like long years of like R, S and S plus was in use, and later R was kind of developed on top of that. Okay, but the beta version of R was released only in 2000. So 8 years they were working on it to release the beta version itself. Okay, so who created R is like two professors who are into research created this R. They're Ross and Robert. Okay, they are actually professors in University of Auckland in New Zealand. Okay, so both of their first name starts with R. That's why it has been named as R. Okay, since it is like based out of S and S plus, the looks and the programming is kind of little similar to S. Okay, so this is the background of R. Okay, why people has to go for R? It's actually open source software. It was an open source software since it was initiated long back. Okay, in that period, the open source software were like kind of were available, but for statistical computing, R is the only open source software available. SPSS was available, but for that you have to pay. Okay, it's not an open source. You can just get a trial of around 2 or 3 weeks. Okay, when you install SPSS. Okay, it has a GUI. Okay, and then I hope everybody knows what is a GUI, and that it has lot of packages. Okay, it has around 10,000 plus packages. I mean, earlier it was 10,000 plus, right now it was even more. So there is a lot of packages which is maintained by 6,000 plus people. Okay, so which has, I mean, I think we'll talk about what is a package and what is a library. All these packages will be like stored in libraries, and then you have to call for it to do a particular function. Okay, so and to get into this, like all the other programs, you don't have to have a computer science background. Okay, and most of the times the math professors use it, and people who are doing the research or PhD, and then people who are like trying to find out some discoveries, and necessarily they don't have to be professors or researchers, but if they're trying to do something in their job to help their business, as they also use R. So where R is being used? It is used for statistical computation, I mean, in the area of hypothesis testing and all, it is used in predictive analytics, where you have to like apply your regression algorithms, your classification algorithms, your decision trees, random forest. I mean, in the area of ML, it is used. In data visualization, it is used. I think you all know what is data visualization, to create uh, better charts so that you can like visualize your data for better understanding. That's what R is used for. And for data mining, it is also used to like collect the collect and explore the data. Most of the times it has been, your data has been stored in on SQL Server, MySQL, or in Oracle. So to explore the data, it's been like connected to your databases, and then R is being used. I mean, usually people use clustering techniques to understand the data here, and data manipulation, and to do data cleaning. So sometimes you have a lot of missing values, or you'll be having a lot of unnecessary data stored in it. A lot of noise will be there, and you it has been R has been used to do that. With R, you can load any files. You can load a SPSS file, your XLS format, or a SAS. I think you all know about SAS. SAS is also like a statistical tool like R, but it also has a GUI, but it's a paid tool, unlike R. SAS has been used by a lot of analysts and researchers, but you have to pay for it. The companies to do statistical computing, they just use SAS, and it's comparatively easier. You don't have to code always in SAS like R. Okay, so before Python was in the being, there was a great war between SAS and R. You can say that. So R and RStudio, actually two things are totally different. Don't think both are same. I've been asked you to install both R and RStudio earlier, right? So R is actually a programming language. Okay, whereas RStudio is your IDE, where you will be like working in R. Okay, so there is a if you install just R, you can still work on programming in R. But if you just only install RStudio, you cannot work on, because it runs on top of R. You have to install both R and RStudio to work on RStudio. But you can just like install R, and then you can just start working. Okay, and if you want to like know more about R, okay, yeah, these are the few links that you can just like go into this, and then try to understand more about R. Okay. Okay, so now I think we'll be moving towards R. I guess you have installed the R already, because I gave you the links for downloading R in RStudio earlier. Hope you have installed after downloading that. Okay, if you have installed and opened RStudio, this is how it looks like. So you have to open RStudio. So when you double click and open the RStudio, you will be seeing like a screen like this. So it has 4 quadrants here. The first one, the first quadrant here, it's called as a source pane, where you'll be like typing your commands. Okay, and here you have a console where your results will be like shown. Okay, even you can type in console pane your commands, but it will not be like stored. But when you like type it in here, it will be like kind of stored there. Okay, it will be easy to access your codes. You can save it. Okay, so this is your workspace pane. Okay, here I mean whatever variables that or data that you have stored will appear here. Okay, so you can just open a new document and save, open a new file, and save the file. All these things can be like visible here, and here you can see all the charts, graphs. Okay, this is a place where you can able to visualize your data. And also if you're like kind of confused about a command, for example, you can seek help function. So that will be like, you can see it. For example, you have a function and you don't know what does it, you can just have to like type question mark and give the function. You'll try to find out, okay, what the function is about. You can see that here, and you can search about functions here. Okay, so these are the 4 uh, panes of RStudio. This is how it looks like when you were working. Okay, here you're plotting, giving your comments. Here you're seeing the output, and all your data has been, like, whatever is stored, you can see that here. And this is where you can see your charts. Okay, this is how it looks like. So now let's get into the basics of R. Okay, so now first we are trying to install few R packages to start with. Okay, I want you to like listen to this first. Okay, so packages are nothing but a collection of R functions. What are the functions that you will be needing will be like written, and then it will be like stored in a package. These packages are stored in libraries. So if you want to use a particular function, you have to call that particular package and installed it from the library. Okay. So usually when you install R, you will be having a default packages which is installed along with R. But sometimes few other packages will not be like installed with the regular RStudio and R. Okay, so for that you have to install that packages. So I'll show you how we have to install that. Okay. Okay, so this is what now I'm trying to install a package called Lattice. Lattice is a advanced data visualization package in R. Okay, so for installing the package, I'm just giving install dot packages within the brackets. I'm and double quotations. I'm giving packages name. Lattice is my package name, so I'm just giving this, and then I can do that. When you run it, this will get installed. Okay, and update packages. Sometimes like you might have installed this package like 1 or 2 years before, and then there'll be like some updates will be like provided, and in that case you can just give update packages. And if you want to like detach a package, you have to give detach and your package name and unload equal to true. And if you want to remove the package, you just have to give a remove package. Okay, so I'll show this in R how it works. Okay, I'll be like sharing my R screen now. Okay, so I guess I have installed Lattice already, but still show you how it works. So no, it's not installed. Okay, it's working. So for to run the command, you have to click on Control plus Enter. Okay, or you can here you will be having a run command button, so you can just press this, or you can just hit run. Okay, so I have downloaded and installed, and then you have to call out that library. Okay, to call out the library, you have to run this. Okay, and if you want to understand what Lattice is, you have to like provide double question marks, and then you can ask. I am just running it, and then all your search results comes in here, and then you can just go and explore. Okay, so and if for example this Lattice was kind of updated, installed long back, and if you want to update it, you have to give update.packages. This gets updated, and imagine that you have to like detach the package right now, because you called for the package. When you call for the package, you have to give library Lattice. When you want to like detach it, you have to give detach. I'm detaching it. It's done. Now I'm going to remove this. Oh, this has been removed. So when I have to use Lattice again, I have to install. So now I'm going to do the same thing for foreign. Actually, this is your task. You're supposed to do that. Since this is being the first task, I'm doing it for you. Okay. So foreign package is being installed, and then I'm calling out the package, and then I'm updating it, detaching it, removing it. Okay, so when you see my codes, you can see a lot of comments saying that I have like carry out some functions in the package. So when here it won't get, you can't run this because you have a hash symbol here. So when you put on a hash symbol, you don't have that command will not be like able to run. Okay. Now we'll be looking into the few basic operations. Okay. So to know the path of the program right now. Okay. So to know the working directory right now, you can just give the function get WD. So now this is my present working directory, and I want to change it to downloads. I'm setting the working directory to downloads. Here I cannot set the downloads because I'm not giving the path, but maybe you can just give the right path, like C download and all, it will work. Okay, and then you can check whether it's working or not. You should be doing this. Okay, and then you can define any variable. For example, if a, you can just say, I think you all know what is a variable and the value attached to it. So here the variable a, and the value of a is 1. So we are giving a equal to 1. Or the other way of giving it is like you can give the symbol. So here this less than symbol and the hyphen means equal to. Okay. Either you can give a equal to 1 or a, this assignment operator, and 1. Okay, so when you print, you can either give print a or just a, it will be, you'll be able to print. And if you want to remove that variable, see, I just gave a equal to 1, this appears here. So whatever the variable that I'm assigning, it will appear in your global environment. Okay. So I want to remove this a. So rm of a, this is kind of, this a is gone from your global environment, and I am like kind of typing printing a, it's not working. So now I'm assigning 55 to a. When I print it, it comes 55. For example, you can assign 55 to a, and then also you can assign to 1 to a, which means here you can see in the global environment 55 is replaced by 1. So whatever that you run until last for assigning your variable, that gets stored in your global environment forever. Okay, so I've told you this already, right? So you can use a question mark to get more information on that particular function. So for example, you want to understand what is a plot, you can just give one question mark. Okay, it just tells you what is a plot and where it is being found. And then if you want to get more help on this, you can give double question mark. So it just like let you know like where a plot is being used completely. Okay, it's kind of a more comprehensive help. Okay, so you can do other things. You can take a square root and then all these things. So for example, I'm assigning a equal to 49, and then I'm taking square root of a, I'm getting 7. Okay, so you don't have to think that, okay, I can only assign a numerical value to this variable. You can assign a string as well. Okay, but the string has to be used with double quotation. Okay, so here b, I'm assigning a b value is a string which says the dog ate my cooking. Okay, so right now I'm just listing things. So when I just give ls, it will list what are the variables that you have stored in your global environment. So I have both a and b stored in my global environment, that comes out here. Okay, I can print b when I have assigned uppercase b to the string, but when I try to print the lowercase b, it says the object b is not found. So which means r is completely case sensitive. Okay, it's completely case sensitive. You can't even, like, even if you give a print command, it's not working. So there is like few built-in functions, okay, where you can just like go on print. And for example, I have letters. So when I just give letters in the uppercase, I can print all my uppercase alphabets. But when I give letters in lowercase, all the lowercase alphabet gets printed. And when I give pi, the pi value of 3.14 gets printed. Month name, all your month name gets printed. Okay. Next, we'll be like looking into assignment operators. Okay. So I already told you equal to is being used for assignment operator, and also this symbol of less than and hyphen is also being used for assignment operators. Okay. So you have this arithmetic operators. You know the addition, subtraction, multiplication, division. Everything works in R as well. So 2 plus 2, you can see this 2 plus 2 is being like all the commands that you give will be highlighted in blue color and the output will be in black color. Okay, please know that. So I just gave 2 plus 2 it comes at 4. So you can also assign that to a variable. For example, for the subtraction, I'm just giving f equal to 6 minus 2, which is 4. So you can run that. Okay. So here you can't print it because it will just compute and get stored in f. When you want to know that, you have to print it. Okay. So here g is equal to minus 45 into minus 8. Okay, the answer is minus 360. So the division 22 divided by 123 is 0.17. And you can also like do a logarithmic functions here. Log of 2 you can do log of 3, 4, 5, and square root of 4 comes here, and you can do multiplication. Okay, so division you have to understand. So you if it is a fraction that you can't solve, so what you can do, you can able to try to know what is the remainder only, what is the quotient. You can just use this. So when you just like give 9 divided by 2, you get 4.5. Okay, but you want to know only the remainder. Here it's 1. So for that you have to use 2% symbol. Okay, so here you get only the remainder. To get only the quotient without decimal places, you have to use percentage divided by simple and percentage. So this gives you the quotient. Okay. Next comes the relational operators. Okay. So this relational operators, I mean, you're trying to find out which is greater and which is not. Okay. So we are asking is 4 less than 6. It gives true. So the output for this is most of the time it's true or false. It's always true or false. Okay. Here 4 is greater than 6. The answer is false. So here you can use the assignment operators, compute the relation operators, okay, to work on the relation operators. Okay, so I'm assigning 8 to x, 9 to y, and then I'm asking is x is less than or equal to 5. Yes, but here in this case I'm asking x is greater than or equal to 5. No, it's false. I'm assigning. No, I'm asking is x is equal to 8. So when you just like give only one equal to sign, it is a assignment operator. But when you use two equal to signs, it is a relation operator. You're asking whether x is equal to 8. So here I've already assigned x is equal to 8, right? So it says it's true. But I'm asking whether x is not equal to 8. It's false. Okay. For your inference, you can say, so I'm assigning m equal to 7 and I'm printing m at 7. Here I have m double equal to 7. So which means it prints true. So here I'm asking is m is equal to 7. So when you use two equal to symbols, it's the relationship operator. Okay. And then now we'll be looking into logical operators. So here you'll be using and symbol and or symbol. So when you use and symbol, I think you should have like known this already. Okay. If you have like learned Python and C before this, I am sure you'll be like completely good in operators. So that's why I'm just kind of uh, rushing this out. Okay. So true and false. So what would be the output? It's false because I have two different things. For and condition, it's always for. But for true conditions, sorry, for all conditions, always because I have one true. Here I'm asking, is 33 less than 44? Yes, it's true. Okay, so here I'm assigning u is less than or equal to 32, which is less than or equal to 44. Okay, I'm asking u, yeah, it's true. I'm assigning I'm assigning a condition here, a logical operator here. 33 is less than or equal to 44. Okay, so the output gets stored in u, which is true, and then when you print u, true comes out. Here, you can assign this condition of 24 less than 54, and then run it. Output false gets stored in v, and then you can print it. Okay, so I have u as true, v as false. Okay, so u and v is always false, but u or v is because you have one true here, and which is not equal to v. I have v false. When you give not equal to v, you have true. Okay. Okay, so I have a list of 0, 1, and true in U. So we'll be like learning list in our data types, the next topic. Okay. So just assign, think right now it's you have 0, 1, and true, three different values assigned to you in the list. You have 0, 1 false assigned to V. Okay. U and V. So when there are multiple objects assigned, I mean, which means you have a list. So it always compares each of the elements. So you have 0 and 0, you have 1 and 1, true and false. So you know you have 0 and 0, both 0. So it's obviously false. 1 and 1, both the values are same, it's 1. True and false, it's false. And you have a double condition, which means here you will be like checking the whole thing. So when you give U and V, it checks each of the elements. But when you give two ampersand symbols, it will be checking the whole thing. Okay. So 0, 1, 0, 1 is the same, but true and false is here it's different. So it will give false. Okay. So when you give U or V, it gives false, true, true. And here it is false. Okay. So I have the same things here. I have given the codes, and then important to tell you this shortcuts here. So to comment and uncomment, either you can just give, you can type the # symbol, or you can use the shortcut Control Shift and C. Okay, and to clear your console, you can just give control here. For example, here I have a lot of things in my console, lot of outputs, and I want it to be cleared. I can just press Control here. Okay, and you can just give escape. For example, if you have like running a command and then it's kind of running forever, you can just like press escape to stop the command. So all these things we have discussed, all the operators. Okay, I have this example for logical operators here. Please check this out. Okay, I'll be sharing this. Please check this out. Okay, you try this.